I don't know about you guys out there in 600X land, but I confess that I'm getting a little tired of the warm-up and ready to build and run a simulation. So let's do that. If we look over here in the idle window, we'll see that we've got 3 functions. They fit nicely on the screen that will actually be sufficient to run the simulation. I want to go over each of them in a little bit of detail, and we'll do that over here on the PowerPoint side. So the first function is walk. Not surprising given what we're working with. It takes 3 arguments, a field, a drunk, and the number of steps to be walked. The first thing it does is it remembers the initial location of the drunk in the field by calling f.getLoc of d. It then runs through a simple for loop for s in range number of steps, f.moveDrunk d. So moves the drunk 1 step each iteration of the loop in the field, and at the end it returns the distance between the start and the final location of the drunk. The next function is simWalks. This will use walk. It takes a number of steps and a number of trials. It begins by creating a drunk, for some reason named Homer. It then places the drunk at the origin, in this case 0, 0, initializes a variable that will be used to keep track of how far the drunk has moved in each of the trials. And then for t in range number of trials, it creates a new field, adds the drunk to the field, and then calls walk, gets a number of steps, and appends it to distances, which eventually it returns. You might be wondering for a minute where this came from. We hadn't talked about that before. Number of trials, which we're iterating over down here. The function simWalk calls walk to simulate 1 walk. Because we're making a bunch of random choices during the walks, we don't want to infer too much about a typical walk from any one walk. After all, we could have one walk in which the drunk just oscillates back and forth across the origin. By running a large number of walks and then aggregating their results, we can get some inclination, some indication of what a typical walk might look like. We'll do that in drunk test. The number of trials, I've just arbitrarily here, I could have made it a parameter, but I've included the number of steps. So we'll take walks ranging from 10 steps to 100,000 steps. For each of those, we'll call simWalks to get a distance, and then we'll print 3 things. How far it was, that is to say how many steps were taken, the mean distance, because remember we're running multiple trials, and the maximum and minimum distances to give us some insight not only into what the average is, but what the variance is. All right, let's go back over here to our idle window and actually run this. All right, we'll run drunk test. Default number of trials is 20. That seems good enough. We'll let it rip. Now if we look at it, we let it rip. We got some distances. And interestingly, if we look at it, we see that indeed, as our intuition had instructed us in the previous segment, the more steps, the further the drunk seems to be from the origin. Well, at this point, we could walk away happy and say, okay, we have the right answer. Life is good. Well, maybe. How do we know? How do we know there's not a bug in the simulation? Well, let's go back and do something we talked about when we talked about debugging. Remember when we talked about debugging, we said that it's always a good idea to run a test case where you know what the answer is and see if you get the expected answer. So let's do that here. I'm going to replace this line by num steps 0 and 1 because I have a pretty good intuition about how far the drunk should go in 0 steps. That is to say, nowhere. And we saw before that when the drunk takes 1 step, he should be moving exactly 1 step from the origin. Let's give this a try and see what happens. Okay, it did give us what we expected, so probably we can feel pretty good about the result. Let's run Let's go back to our original version now. And I'm going to, well, let's just run it and see what we get again. All right, so what I want you to notice here is the first time we ran it, say with 10,000 steps. Did I say 100,000? Maybe that was what I had in the PowerPoint, but not what I have here. When we take 10,000 steps, the maximum was 248. Here, the maximum was 168. Should that make us nervous? Not at all. Remember, it is a random walk, and we do expect to have randomness. A trick worth knowing, however, is that sometimes we want to take the randomness out of a random walk or any random calculation. In particular, if we were to get the wrong answer and we want to debug it, it's nice to get reproducible results. We can do that by using something called random.seed. So let's come over here and type random.seed of, well, any number will do, but I'm going to use 0. But let's go back for a moment to the PowerPoint now, where I'm going to try and show you what's going on. We're looking here at what happens with random.seed. We had talked about random.choice generating a sequence of random choices. In fact, what it generates is a sequence of pseudo-random choices. For our purposes, we don't need to worry too much about the difference between pseudo-random and random. It will give us the same kind of results a true random number generator would give us. But here's the way it works. When we first start it, it generates a sequence of random numbers. Then the first time we need one, it returns the first number, and it returns the second, then it returns the third, etc. These sequences are generated using something called the seed. Depending upon the seed, we get a pseudo-random sequence, a sequence of unpredictable numbers. Typically, the seed is chosen using the system clock, for example, the number of milliseconds since 1978. Since we don't know when the program will be run, that will give us a random result. However, if I write random.seed 0, or 1 or 2 or anything else I care to write, it says use this seed. And then I can use that seed over and over again, and then each test I will get the same random sequence and we'll get the same things. So let's try it over here with drunk test again. So I've run it once. Now I'm going to got a different result from the last one. But now we should get the same result because we're using the same seed. And sure enough, if you compare these two sets of results, you'll see that they are indeed identical. A good trick to keep in mind when you're debugging your programs.